All right. So, hello everyone, and welcome to our next lesson for GAMPRG1, which is about navigation, AI navigation in Unreal. So, Unreal has their own kind of navigation where you're able to tell a AI or AI controller where the character should, what path the character should follow to reach the uh, least least amount of distance to get to it, right? So they have their own thing. See, on Unity has their own as well. I forgot what it's called, but it works on the same premise, I believe, using a navigation mesh. So we'll talk about that for today. Okay. So navigation. This is also recorded, so in any case, you can just watch this later. But anyway, navigation, how can an object move from point A to point B? So if you have a map, sure, you could manually tell it to go forward in this amount of distance, to go right this amount of distance, etc. So you can manually code it however you like, right? But the thing is, it is too inefficient. Why? Because what if you have another map? What if you have a dynamic map? And when it comes to dynamic, you can't manually code how to reach from one point to another. You should be able to find out which path to go to get to that location. So if you have and went to Sir Dale's classes, I think GM Dev AI. So GM Dev AI, he teaches you about A star or some other um, some other navigation kind of way, but different. Iba yung kay Unreal. So instead of manually doing it, we have the AI understand the layout of the level. So they already know how the things are in the level, and we make it navigate through it, avoiding the obstacles and getting to that location. So no worries about being late. How do we do that? So we use something called a navigation mesh. So it is a mesh that stores the data, which areas are walkable and unwalkable in the level. So remember, a mesh, it's something like all of these, right? These are mesh. It's a kind of a plane, right? But what it does is it stores the data, what which is walkable. So all of this place is walkable. All the green means it's walkable. The AI can walk through all this. If it is not green, or if it's red, or it's not even highlighted at all, these are not walkable. So we do this with the use of a navigation mesh bounce volume, or nav mesh bounce volume. So what it does is objects within this volume are read by the navigation system. So we use something like, it's like a collider. If you check it in Unreal, it's like a collider or a trigger. But what it does is it reads everything that's inside it, and it will set which plane, what are the planes that are walkable. So I'll demo it later. Oh, questions here? Nav mesh. Let's put this in the side. Question about nav mesh. So all it does is in that trigger, in that volume, it it tells which area is walkable or not. Okay, so that's it. For pathfinding, this is how the AI decides to move around. So what it does, it will trace the nav mesh and determine the shortest path. So let's say from here to here, it will determine which one is the shortest path. Either maybe here, or maybe walking here, maybe walking up here, down there. But what it does, it uses a its own their own algorithm to find out what is the best path to go to so that it will reach its location the fastest way. Okay, so AI can only move within the nav mesh. That's important. If you are outside the nav mesh or whatever the location is outside the nav mesh, it will not be able to go to it. It will give an error, not error, but it will say that it's not able to go to it. So we use these functions based on what we need. So there's a function called simple move to location. So simple move to location, it's as simple as telling what is the AI controller and where should I go. Same thing, there's a simple move to actor where this is the AI controller and the goal is an actor. So if you run this, whatever the AI controller is on the character, it'll start using it and then it'll go to it. If you want something more specific, you could use the move to location or move to actor. So what it has is acceptance radius, meaning how close could it be so that it would accept it, that it has already reached its location. We could use pathfinding or not. We could use like a filter class, meaning maybe you want a certain class to only use this, right? So there's a thing. Same thing in move to actor, it has acceptance radius, use pathfinding, etc. The return value, this one tells if it has successfully reached or it has already like it's on the way to it or maybe it wasn't able to go to it. So that's the return value. It's a enum. Right, it's just an enum. It just tells you if it has successfully tracked its location. Right here. So it is a result. Right? Questions? Maybe when we demo it. Okay, so demo. Uh, so this is your Unreal, right? If you don't have place actors here, because this is what's important. This is where we get the nav mesh bounce volume. So if you don't have that, it's in Window, Place Actors. Okay, so this is where we have the place actors. We use this to get the player start, or to get some volumes, or to put some light. But in here, we have volumes. And if you scroll through it, we have nav mesh bounce volume. So this is the one that we need. Nav mesh bounce volume. So what does it do? So it looks like a collider, right? It looks like a collider. Let me make it bigger. Maybe you can see it more. There. So it looks like a collider. But if you actually press show and navigation, it shows the green nav mesh. So again, you can go press show, navigation. If you don't want that, you can just press P. So this is me pressing P. So it will show. So what do we do with this nav mesh? If you want a certain area to be covered with a nav mesh, let me use this nav mesh bounce volume. Oops, sorry. Here. Right, so each time you move it around, it will update. And if you change its size, so you can use the brush settings or the scale. So brush settings, same thing, it just scales it. There. So this is our nav mesh. This is our navigation mesh. So it is created within this nav mesh bounce volume. So how do we use it? Let's go create a character or a zombie character. Let me just save this. Alright, so it's still there. If I go to zombie, it's just a character. This is just a character. I'll just add a skeletal mesh. Move it to the right. Look, make it look to the right. Okay. So here's our zombie. So if you try like event begin play, let's use no. Uh, simple move to. Alright, so there's that simple move to actor. So you can search it. Simple move to location. So there's these two. So for now, let's say it move to actor. The controller, it needs a controller. So we can just say get controller. So get controller is a function of a character. What it does, it returns the whatever is the controller of this. So that's get controller. The goal, let's say I want to get the player character. Get player character. So this is a function that you can access anywhere, but what it does, it will return the player character of player index 0, which is always the player. So let's set this up. That is the goal. So on begin play, we want it to move to the character. So let's try out. Let's move here. Here's our zombie. If you press play, our zombie is now, or our character is now chasing us. Alright. So again, if I press play, our zombie is right here. On the corner, we are spawning here. So when you press play, he is there, chasing us. And you notice, it'll stop chasing us when you reach here. Why is that? Why do you think it stops chasing us there? Anyone? Why do you think the zombie stops chasing us when you reached here? So all I did was move backwards. And now it stops chasing. Does anyone have an idea? Nav mesh stops there. That's correct. Because kind of correct. So remember that it is trying to chase this. However, since the character, right? Since the character left the nav mesh, it does not know anymore where it is. It has no location because it is not within the nav mesh of the level. And because of that, it stops. We try. Oh yeah, we don't have it. Okay. So that's the idea. So in here, same thing. If we try this location, so if I use this one, the goal, let's get the location. Okay, so on begin play, we will make the AI move to this location. Press play. Now, why do you think it moved there? Why didn't it try to follow me like a while ago? Anyone? Why do you think that a while ago it was chasing me, right? But now it only goes to that location. Why do you think that is? So press play. You'll see that it's just going to that location instead of following me. compared to this one. This one, it tried to follow me, right? There. It's trying to follow me. But this one, the simple move to location, it only went to that location. Simple move to location tells zombie to go to the said location. Yeah, yeah, that's correct. Correct. So, because I said on begin play, go to this location. I didn't tell it to follow this actor. I only said it to go to this location. So at this frame where this was called, it will try to go to this location and nowhere else. Unlike this one, since we said the goal is an actor, it will try to go to that actor no matter what. Hence, it will still try to move. Even though I was moving, it was following it. Okay, so that's the idea of simple move to actor and simple move to location. So if we, there's also the odd one, right? We also have the move to actor. So you'll see it's not available here. We have simple move to, if you have to move to location or actor, but move to actor is not here. Why? Move to actor is actually a AI controller function. There you see it's under AI. To access that, the pawn, we can cast it. Oh wait, let me search AI. Oh, we can do this. Actually, we can just cast this to AI controller. We can do this, same thing. Or we could just use this, get AI controller, and then the controlled actor is self. So this is the same thing. We're trying to get the AI controller. So both will work. Okay. Okay. So for here, AI controller, we have move to actor. This is where we have the additional settings. Can strafe, allow partial path, filter class. So there's that. So this one, yeah, for navigation. But we don't really touch on this unless you want a specific kind of filter. But anyway, for acceptance, we can go maybe they have to be within 500 units. The goal, our player character. So you'll notice it will follow me and it will stop there. Why? Because he is within 500 unit radius. So we do that in case that your zombie or whatever is like moving left and right because it's trying to reach a acceptance radius of -1. So if you want, you can give it a radius so that it doesn't try to go left and right and glitch out. Same thing. So if you go here, there. Okay. So same thing. We can also access move to location. So you'll see I'm using this one. I can choose not to use this. Go straight to the point. Destination will be our actor, our player character's location. For this one, in case you don't know, you can actually put a node in between a line. If you double click, there. So just to make our lines cleaner. Alright, so if we play this, it will still follow that location. Alright, so those are the options. Well, actually, one more. Besides all of these, move to location, move to actor. You saw a while ago, move to actor. location or actor. So this one, it is a it's called a task. It actually has its own what you call this execution. So either you can just continue, or you can, if in case the request failed, you can run this. In case the move finished, you can run this. So this is actually a bunch of code inside that uses move to actor or move to location. So how this works is the same thing. We can either use a actor or a location. But there's one thing that I like about this. It is this. Use continuous goal tracking. A while ago, you noticed that the zombie or our character stops moving when it has reached its location. This use continuous goal tracking. It is useful if in case you want to make it continue to follow no matter what. So even though it has reached its location, it is still following me. Alright, so that's one thing that's useful. Another useful thing is this. So we can always, so here, we can print string here. This is begin play. This is request failed. And this is move finished. So you see there begin play. So it didn't move finish because we said continuous goal tracking. And then finally move finish because it could not move to me anymore. The request failed only happens when maybe wherever we are outside, or wherever actor location the actor is outside the nav mesh. There you see request failed. It appears there. Request failed. Right? Questions? Clarifications about this? None? Okay. We can continue. So we have the navigation mesh, but what happens when we have moving things? Or maybe not moving things, but things that maybe spawn inside the nav mesh. So for procedural level generation, the layout of the level is generated during runtime. So it doesn't apply at the start, but it is applied during runtime when the game is running. So if levels generated runtime, nav mesh must be generated runtime as well. We do this by setting the runtime generation to dynamic. What it will do, it will detect the changes within the nav mesh bounce volume and generate an updated nav mesh. So if you see here, let's put a block. You see that the nav mesh is not around the block because it is blocking it. But notice that if I move this block, let me just make this a movable. If I move the block, the nav mesh will not update because it is in static mode, meaning it is generated at the start of the level and it will not generate anymore. So it will be useful if maybe you don't have any blocking things that will appear during runtime. It'll save in your performance. However, if you have things that could move within the level, or do you have enemies that would spawn, it is better to have it dynamic. So this one, this runtime generation, it is in Edit, Project Settings, Navigation, Mesh. So in here, you'll see the runtime generation. You can choose to search it also. Runtime generation. This should appear under navigation mesh. This is where you can set it to dynamic. So if you set it dynamic, it is now dynamic. If you move this, the nav mesh updates. Okay, so that's the dynamic. So you have to know that. Then, besides that, we have something called dynamic obstacles. This is where you want certain actors to act like a obstacle for the navigation, but you want it to act it. You want to make it act in a certain way. What do you mean? What if you want a obstacle where the AI has to crouch down? So how do we do that? There's an actual class for it. It will be called I think crouch only or something class. So we have to set that. Or what if you want an obstacle where sure it blocks the way of an AI. However, what if there's no way to get to the other side for the AI? So you can set it so that in case there's no way for the AI to get to the other side, it can go through that instead. It'll pass through it. So I'll show you. So not here, let's create an actor. Let's call it a wall. Let's give it a collision, box collision. Okay, so that's our box collision. Maybe I want to extend its X, maybe 800. Right. So the dynamic obstacle, it's here. Dynamic obstacle. And you'll notice that, oops. Do I need static mesh? Okay. So we have a settings here. Low height, null, obstacle, default. So usually it's default, but if you want a certain path like this one, the obstacle, if you read it, it represents a high cost area that shouldn't be traversed by anyone unless no other path exists. So if I try that, compile, you'll notice if I put this here, it's orange. This one's really blank. This one's orange. So this means it's kind of special. So how special is it? In case there is no way for the... Oh, let's make an actual block. If there's no other way, let's put that there. And there. So let's make it, let's delay this for maybe just 2 seconds. After 2 seconds, it will try to go to the player. So you'll notice if I play this, it will go through that area. But if there is an opening, so maybe it's right here. This, let's make it a bit bigger. If there is an opening, instead of going through here, it will still think that this is an obstacle and it will pass through here instead. Yeah, you see it? It's passing through there. And then reach me. So that's the obstacle. There are other more options that you can use. Maybe you want low height, where it's only for I don't know. Yeah, yeah. Just in case that maybe there's an opening but it's too low, but for some reason the AI can actually navigate through it. You can use this AI null height. What's it? Low height. So what it does, it still blocks the area. It still blocks for the player, for the AI. Yeah, it's still blocking it. It's still trying, but it's blocking. So maybe, just maybe you want something like this on your level, because it looks like it can be traversed, right? But we use that so that we can say no, this is still blocking. Okay, so you can play around. You can play around with those settings. So again, it is in the navigation. Let me check if we can see it for static mesh. Ano ko hindi? Yeah, yeah, yeah. Hindi nga. It's only for colliders where we have that settings here. Questions so far? Or clarification for dynamic obstacles and runtime generation? Dynamic runtime generation. Again, in case you forget, edit, project settings, runtime generation right here. Or you can just go to navigation mesh, runtime generation. Limit? What kind of limit do you want to know about? And there's no limit naman to it. They can actually can even increase the volume. Go horizontal.
Hi, I said the question. Could
Yeah,
certain of these things overlap with each other? Is that like a bad thing?
certain things overlap. Uh,
Like, could the navigations meshes overlap, or would that be a bad thing generally?
not really, because you can have like this one. Remember a while ago, we have this obstacle where in case there's no way the player can pass through, but through here it will pass through. You can have this down here, maybe like that. So these are two navigation. These are two obstacles overlapping each other. But you'll see that uh, for this it will actually clear it out because it's really blocking. But it still have some of these here. So what will happen is, in case there's no way, still it'll pass through one of these. In this case, probably this one because it's closer. Yeah. So you can make it overlap. You just have to check the navigation, see if it's what you want. Okay.
Okay, thanks, sir.
Any more questions? All right. Nav modifier. So, oh, sorry, that's what you're talking about. Uh, yeah, 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 my bad. So this dynamic, you see this dynamic obstacle. In case you have a moving object in your level, you want to use dynamic obstacle so that when it moves, it'll actually affect the nav, the nav mesh. So let's try that out. Let me put a cube here. It's a cube, but we're just gonna close. I mean, we're gonna disable its physics. See if you don't remember, this is physics. So no collision. So it's really just there as a something that we can see. So our wall here. Ah, uh, let me return this nav default. Hold on. Okay, so it's there. But what if we try to make it move every tick? Maybe set actor location, add actor world offset. Let's make it go to the left. Every Let's make it go to the left 100 units to the left every frame, every second. So you'll notice it is updating every every frame. But if we close this dynamic obstacle, I believe it shouldn't update there. Because we turn it off, the obstacle, they don't know where it is anymore. So we need to have that setting, dynamic obstacle. So if you turn it on, it is now dynamic. Okay. So sorry, I thought the nav modifier instead of the dynamic obstacle. So yeah, you know this already. Okay. Now here, what if we have a really huge level, like our open world level? So generating a big nav mesh for an open world level is too expensive. What does that mean? It will take too much processing for the game to know what should be walkable or not. Because imagine it is trying to check all the planes in that nav mesh bounce volume. Okay, so you can try that out. There's actually a level here. This one. So we have this open world. If we add a nav mesh bounce volume, watch as my computer tries to calculate the nav mesh as I increase this. Okay, so that's just X. So this is not even close to the whole thing. So I have to increase it more. More. There. You see the struggle now. And I haven't even done the Y yet. I do the Y. There's a problem. It's too huge. Imagine it hasn't even fully done the nav mesh yet. And what if you have moving objects in between? That's where your computer starts struggling. Okay, so this is a problem. In order to get what did I do? Oh, hold on. Have. Ah, crashed. Okay, so it's a problem. One way to go through this problem is to use something called a navigation invoker. What this does is it will create the nav mesh around these invokers instead of on the whole volume. So why would you do that? Not you don't need the whole thing, the whole place to have a nav mesh. What if you want this uh what if you want a character or actor to just follow you? So what it does is it will just try to go within the nav mesh around your character. Okay? Or what if it wants to go to one place to another? Instead of having the whole area to be nav mesh, you can just have those two areas to be a nav mesh. And then it'll just follow that. So nav mesh once only should cover the entire area of the map still, but you'll notice something else. So balik ulit tayo lang. So we're back here. If I go to edit, project settings, and to navigation system, here you have this. Generate navigation only around navigation invokers. So if you tick this, what happens is when you put a navigation nav mesh bounce volume, if I press P, it does not appear. If you see here, it's P, right? Naka-on siya, but there's no nav mesh that is appearing. Kahit na gawin ko tong malaki, wala pa rin. Kahit if you add the Z, still none. Okay, does not appear. But we have the whole nav mesh in this map. What we can do is, let's say our zombie. Let's say the zombie should only have a nav mesh around it. So if you add here, add navigation invoker, this is the one. If I click this is where it'll only create a nav mesh around the actor or character. You can change the settings. What if you want a bigger area? Then we just use this. Tile generation radius, we can maybe say 10,000 around. That 10. Oh no, that's not 10. That's not 10. That's 100. And then maybe 12,000. Okay, so that's 10,000 units around our zombie. You notice outside of it, there's not. Right. So if we put a nav mesh, sorry, not nav mesh. If I player start here in this corner where yeah, if I put it here, I'll spawn in front of it. You see it'll start to move. It is now trying to chase me, and you notice the nav mesh is also moving because it is based on the navigation invoker. So it doesn't have to be just one. You can have multiple zombies with it in the level. It's okay. You can even give yourself a navigation invoker. So I am using third person. So let's put a navigation invoker here. There. If I press play, you'll notice compile. It's only 3,000. Yeah, it's only 3,000, so sakop na ako. Yeah. So yeah, you'll see they are both now going to me. So that's the use for navigation invoker. So this is only useful for open maps. We don't use this for our level. Bakit? Our level is a procedurally generated level. It's not a huge map. It's an infinite map. It's infinitely forward. So if you use a nav mesh bounce volume, kahit gawin mong 1 million, what if yung 1 million yung size? What if the player passed that 1 million magically? Maybe they were just that good. When they reach that, all the zombies will not be able to follow anywhere because they are outside the nav mesh. Okay, so this is only for big levels. So yeah, you don't have to use this for your zombie. Okay, so this is only for big levels. Questions here? No questions. Okay. Sige. So what do we do for a procedurally generated level? What we can do is we can generate a nav mesh on demand. What does that mean? Instead of having it uh, update every frame, we can make it update on a certain time, depending on our what option we use. Okay, so when level procedurally expands, we have to expand or move the nav mesh bounce volume as well. So explicitly issuing an update request through on navigation bounce update forces the system to regenerate the nav mesh. So I'll show you. Let's go back to our level. And let's bring back the settings for navigation invoker because I do not want it. I'll close that. Where am I? Here. Okay, so I closed it. So now we should have a nav mesh here. Okay, so the thing is, why don't we just have a nav mesh bounce volume around the zombie? Right, that's one question that some people would ask. It's because you can't actually create a nav mesh in here. Bounce volume. We have volumetric cloud, but we don't have nav mesh bounce volume here. Okay, that's why we are not able to just put it around. It can only be placed on the level through here. So what we can do though is we can make it follow the player. We can make the nav mesh bounce volume follow the player using a code, using some code. Okay, so it says here level blueprint is the best place to update navigation bounds. Bakit? Here's our nav mesh. To access the level blueprint, go to this and open level blueprint. So this button, press it, open level blueprint. This is the level, this is the blueprint of the level. If you see here, if I right click, there's a create a reference to nav mesh bounce volume. So this is only available dito sa here in the level blueprint. I'm able to get a reference of objects in the level through this level blueprint. So you'll see here, I selected this box, this cube 2. If I right click here, create reference to cube 2. Okay, so what we can do, if we want to manually move it, we have to use the on navigation bounce volume. So get navigation system. This one is in the Dropbox naman, so you can follow it, I think. Yeah. And then on navigation bounce. On navigation. Update. So we're updating it. So every frame we will update it. But what is the location? What location should it be? Let's make this thing go to the location of our character. So this is the navigation bounds volume. I want its location to be where our player character is. All I did is set the location of our navmesh bounds volume to our player character's location. And then we update it. So important also our navmesh bounds volume. It's static here, right? If I press play, there's an error that's gonna appear. Lots of error. It's gonna say that it has to be movable. So you have to make it movable. Since it's not movable, we can make it move. And you'll notice it's always red. If I move here, it has now updated to the right, but it's still red. Why do you think it's still red? Our nav mesh bounce volume is now following us, but the problem is it is red, which means it's not it's still calculating. So why do you think so? Why is it color red? Anyone? Why do you think that it is always red? Why do you think it's always calculating? None? Okay. It is color red, or it's trying to calculate because every frame we are making it update, which is bad. We do not want it to update every frame because it is forever trying to calculate. So what we can do, we can have a delay. Every something seconds, it will update. So instead, maybe put it on a timer. Maybe every second, we'll make it update. Not this one. Custom event. Move. We make it loop. So this timer, it will run this event every second because I'm looping it. So every second, it will move the location and update the bounce. So you'll now notice every frame, every second, it turns red. So you can actually increase it more in case, okay, it crashed. In case it's too much. So you can add more delay into it. Bits, bit array. Yep. So yeah, put a delay. Oops. Wait, sorry. So let's generate nav mesh on demand. So this is the one that you'll be using instead because it is much better and it's not gonna, there's no limit to how far your nav mesh will be because it's always just following the character. I don't think I saved this. Yeah, I didn't save it. So again, all I did was make it move every second. But let's make it every 2 seconds. Set timer by event. Create custom event. Move nav mesh bounce volume. Can name it anything you want. And then get navigation system update. Set this location. Nope. Set actor location to the player. Get player character. Get actor location. So we set it to the player. Make this run every 2 seconds. And don't forget, movable. Do that, and I did not change the navigation. Navigation has to be dynamic. Oh, I did. Sorry. There. So every 2 seconds, it is updating. So this is better. This is better than every frame. It's much easier for your computer, and everyone's happy. Okay, so that's how it works. Any questions or clarification about this? No clarification? All good? No questions? Okay. I believe in you guys. Okay. Wait lang. Let me ask. Communication mesh. Sige. Let's just brainstorm a little bit. How do we make our zombie follow the player? How do we make it follow the player? Anyone? What code would you use? Get after transform, tracking the players within the nav mesh. The problem is our nav mesh will be always around the player. So it should be always within the nav mesh. We don't want our nav mesh to be following the zombie. Why? Because there's going to be multiple zombies. So instead of making it follow the zombies, we should make our nav mesh follow the player. So the player will always be within the nav mesh. Actor transform. What about the actor transform? What do you want to do with the actor transform? James? All right. Anyone else? How would you make our there's some kinda actor transfer, but not really, because if let's say maybe we want to know all the distance of the zombie to the player, uh it could work. Maybe all the zombies has to check where the player is if it's within a certain distance. So that would maybe look like this. On every tick, get app, get player character. On every tick, get actor location. We want to know the distance. Distance of this, of our zombie to the player. And if it's within a certain distance, maybe it is less than or equal to 1000, it will start chasing. So there's this. Sure, but what I don't like about this is this part. This is what I don't like. The get player character. Why? Because since I have this, for me it feels cheating. Like this I know you can access this anywhere, but feels cheating because you have access to this everywhere. There's a better way so that we know when the player character has is within its reach or something, or within its view. Okay, so for me, sure, okay lang, but I feel like it's cheating. Okay, so if you want to try it out, here, let's put a print string here. Print string. It's gonna spam hello when I am within 1000 units. There, see? So you know it's working. But for me, it's cheating. Anyone? You think there's a better way than having to always check where the distance, the player character's distance is? See, what other things that we have so that if they are if they are there, it will trigger an event. What other functions or what other components do we have here that we can play around? Having an invisible collider. That's a good idea. So if you have a collider here, an invisible sphere. If you have an invisible sphere, let's see, let's make it reach 1000. That's 1000 units around. If you have this, you could use its events. You could use begin overlap. I'll use begin overlap. So that when a actor enters it, it alerts this. So if an actor like our character enters it, so get cast to third person. If this is our character and it has entered its sphere, it'll run hello, or it'll start chasing. There. So if it has entered this, at least the zombie will now know that the player entered it because we set it to cast to a third person, which is our character. So when he enters it, you can now do like uh move to actor. Get controller, and this will be our goal. So as simple as that, you can have a chase. Right? So simple code. All you have is this two. If the character enters the sphere, chase. Diba? Dali lang yan. Now, when it comes to attacking, that's another thing. You have to have some other check. But, yeah. So in this case, you don't have to use like navigation invoker because again, we have a infinitely generating level, and invoker, the navigation invoker is only good for big levels, not a infinity generated level. And to update it using this, it's in the Dropbox naman, so you can follow that. 3, this is one way. This is one way to know if the player is within uh, the reach of the zombie to chase. Okay, so if you want a dynamic size, I mean, you can always change the sphere here, right? Sphere radius, or you can maybe change the sphere radius here. Set radius, right? Maybe you can have a float like variable. Uh, what's this? Chase radius. It's a float. We can have this instead. So you'll notice if I change the radius, it also changes the size. Oh, magic. It's because it's on the construction script. Okay, so if you want, you can do that. Up to you. You can do other things naman. Or you can just manually change it for every zombie. Okay? Any questions or clarification? None? So, so yeah. Another tip, you can have another sphere for attacking. Okay, no bahala how you do that. You can have another sphere for attacking. If it's within that sphere, start attacking the player. If they exit the sphere, stop attacking a player. So you can do that. That's another tip. Right. So yeah, that's it for today. I hope you learned about navigation. Hope it opens your eyes to maybe creating your own levels in the future, how to use navigation, how you can play around with it. Maybe have like obstacles and stuff. Yeah. So yeah, that's it for today. You can watch this again in Big Sky. It will be under recordings. Last week's recording also is also in there. So if you missed it, you can watch it there. So yeah, so that's it for today. You guys can go and enjoy your evening.